Alright, the first part of this video is going to be talking about factors and prime factorization. This is a topic that you should know a lot about, dealing all the way back as far as second grade. Maybe we talked about what factors are. And factors we know are whole numbers that can be multiplied together to get a product. So if 7 and 8, we call them factors of 56 because 7 times 8 is 56. So anything that we multiply together to get a product, in that case I could say that 2x and 5 would both be factors of 10x, right? Because if I multiply 2x times 5, I would get 10x. So they could also be called factors of this monomial 10x. Alright, well, prime numbers, right, are numbers that have exactly two distinct factors. Alright, this word distinct, right, means different and unique. So exactly two factors. And this is one of the things that sometimes catches students, is that 1 itself is not a prime number because it only has one distinct factor, and that is itself. Prime numbers have two factors, 1 and itself. 1 goes into every number, as 1 is a factor of every whole number, and prime numbers, no other numbers go into them. And we have a good understanding of that. We know what primes are. If I asked you to list off the primes, you would probably be able to give me a good list of them. All right? However, do not start at 1. 1 is not a prime number. All right? You're not allowed to tell me that. Prime factorization is a way to write any number as a product of its prime factors. And typically the way that we have been taught to do this is with a factor tree. It's not the only way, but it is certainly a good way. And then if you remember back to your factor tree days, right, you took 50 and you split it into two factors that made up 50. And we found that it didn't matter if you split it up into 2 times 25 or 10 times 5. You're going to end up in the same position. Right? The Basler rule is I'm always going to take two factors that are closest together. And then we remember that once we get down to a number that is, we take a look at 5 is prime. It doesn't have any, it can't be split up into different factors. So we circle that. You don't really have to, but a lot of us would have done that. 10 we could split up into 5 times 2 or 2 times 5. As a general rule, I will always write them from least to greatest. And 2 is prime. Alright. If I ask you tomorrow to tell me like what is something unique about 2, right? Well, it's the only even prime number. All the other prime numbers are odd because 2 goes into every even number. So no other evens can be prime. Alright, so we've got 5 times 2 times 5. Yuck. Alright, not even going to go away. Okay. I see. So 5 times 2 times 5, and typically we'll probably write it from least to greatest. So 2 times 5 times 5 would be the prime factorization. Now, in 7th grade, we're going to typically write this either out like this, or I could say write the prime factorization with exponents. And since there are two factors of 5, we would probably write this as 2 times 5, and now we'll write the two factors with exponent because we know that the exponent tells me how many times I'm using the base 5 as a factor. Since there are two factors of 5, it would be 2 times 5 to the second, and that would be another way to write the factorization. Either one of these is prime factorization of 50. Alright, so go ahead and do 330. Alright, let's pause it, do 330, come back when you're done. Okay, and then hopefully again, it doesn't matter how you do this. If you did 2 times 165, I feel sorry for you because I think that's a little harder. go closer to the middle. 33 times 10 seemed easy to me. And you see in just 2 steps we get down to all primes. 2 times 3 times 5 times 11 would be the prime factorization of 330. All right, now there is a method in which you simply just divide by. You start with the smallest prime number, which would be 2, and we divide it by 2 until we can't divide it by 2 anymore. And when you have a prime number at the bottom, when you're done, I divided kind of upside down, but if you have a prime number at the bottom, right, then this is your prime factorization. It's 2 times 2 times 2 times 2 times 3 times 3. Now, this is a really good way. You know, number one, it gets them in order, so I like that part of it. So you're all dividing, but again, I just think that's a lot of divisions. You got to do 1, 2, 3, 4, 5, 6, five divisions maybe to get it done. Whereas if we start with 144 and we break it into the two numbers that are closest to the middle, 12 times 12, excuse me, all right, then real quickly we can kind of, 4 times 3, 4 times 3, and then the 4's become 2 times 2. And so we see 2 2's, a 3, 2 2's, and a 3. All right, we'll get the same factorization. Depending on your speed, and how fast you're doing this, once I get to 12 times 12, I kind of know what makes up 12. It's 2 2's and a 3. So since I have 2 of those 12, I know it's 4 2's and 2 3's. And so I can go pretty quickly through my factorization. And as you get a little bit better and faster at it, it becomes a little easier for you. That's certainly one thing. Now, factor tree is good, the prime factorization, because it helps you find all of the factors of a number. So here if I have the number 20, I can go through, again, because I was in 3rd grade, and I know what multiplies to 20, 1 and 20, 2 and 10, 4 and 5, and so those are the factors of 20, 1, 2, 4, 5, 10, and 20. The prime factorization of 20 is 2 times 2 times 5. If you did a factor tree, that's what you would get, right? The neat thing about prime factorization is, other than 1, every factor, right, every factor of 20 is in here in some form. 2 times 2 times 5. So 1 is a factor of every number. If I just took this factor 2 by itself, that's 2, right? So that's a factor. If I took these two factors of 2, 2 times 2 is 4. That's a factor. If I took this number by itself, this factor of 5 by itself, 5 is a factor. If I did 5 and 2 and this combination, 5 times 2 is 10, that's a factor. And if I multiply 2 times 2 times 5, that's 20, and that's a factor. In fact, as you go through and exhaust all your combinations, right, of these primes, you're going to have all of the factors of the given number. Even if it's a very large number, if you exhaust and go through all of your combinations of the prime factors, you'll have all the factors of the number. So every factor of 20 is hidden in here somewhere, other than 1, which goes into every number. And that's the end of this section. The next section that you're going to watch deals with how we're going to use this for finding GCF and LCM with numbers that are a little tougher. All right, namaste.